Advent of Code 2024, Day 8, Resonant Collinearity. We're going to get a map. It's another grid problem. And the map's going to have a bunch of letters. So lowercase, uppercase, or digit. And each of those means a frequency, but it's not a number. It's just a label. And we need to calculate what they're defining as antinodes. And the antinodes happen when you have any two antennas of the same frequency, same label, where it's a point that is twice as far away from one as the other. So the easiest case to picture is, in the case they picture over and over again, is from here to here. If you take the same distance, so it's like up 1, 2, over 1, up 1, 2, over 1, this is up 2 over 1, and this is up 4 over 2, so it's twice as far. Similarly, go in this direction. It's a little weird because their examples don't include any cases where there's an antinode between two nodes. It's not clear if that's meant to be included or not. Well, look, let's keep that in mind as we go. And let's see, there are examples here, like if there's 3, there's antinodes on both sides here, except for this one's off the map, and like this one's off the map, and off the map ones don't count. And we just need to count the number of antinodes. They do tell us if there's an antinode on top of like, here's an example. There's an antinode on top of this A, it still counts. They don't show it on the map. Yeah, okay, I think that's all we need to know. Let's go ahead and take a look. I'm gonna grab which puzzle input am I using here? Got capital A's and O's. Grab or example input. All right, over here, we will run .genday8. The intro video for this series talks a little bit more about this, but basically it's going to grab my puzzle input and it will make me a stub to work off of. We'll look at the puzzle input. I'm expecting much bigger, a lot more letters. Yeah, so nothing too huge though. Cool. I don't see like hundreds of each. When we do combinations, we don't want to have like tons of letters, but this seems small enough. All right. So what do we do? Well, we need to parse this grid. What do I have? I already have I'm stripping off each line, so I got a list of lines. That's probably good enough to start. So first thing I want to do is parse this map into a list of points for each frequency. So I'm going to call it like, how do you spell antenna? We'll figure this out. Let's see. Antenna is spelled, the real reason you tune into this channel. Antenna, let's call it like that, is equal to, and I'm going to use a default dict. From collections import default dict. Because basically what I want is, I want a list, a dictionary of sets, and every one is going to be empty to start with, and I don't want to check each time does this exist. So I'm going to say like, oh, here's a point that should be in the lowercase a. We'll just say antenna of lowercase a dot add this point. And I don't want to check if that set exists. I just want it to be there. So that's what this is going to do for me. So now I can say for R in, maybe we'll define it because it's always useful. Say num rows equals len lines, num calls equals len lines. I remember pretty clearly they're all the same length, so we can do that. For R in, oh, actually, I don't know why, I don't think I need, well, we might not need that. We can complete it if we want. For R comma line in enumerate lines. For C comma val in enumerate line. Now we can say if val is not equal to, and what we should look at, what's our dot? So we don't care about dots. I'm going to log anything else. If it's not equal to dot, antenna of val dot add, because it's a set, and we'll add R comma C. So now we've added that. And so if we run this, let's see, this, we do Python day whatever example, we get a default dict where 0 has 4 points, and A has 3 points. A has 3, 0 has 4. That's looking right. Okay, so we've read in our antenna. We got them all to different points. Now we just need to loop over each combination of antennas. So we're going to say from itertools import combinations, and that is combinations handles it without order mattering, so that's good. Okay, so we can say for how am I gonna say this? Let's say I think it's gonna look like R1C1 comma R2C2. I might have my spacing a bit off here, but we'll see. In combinations of and antenna. Oh, actually, hold on. We need to say for I guess we call it freq in antenna. Then we'll say for R1C1 in combinations of antenna freq. Now we're gonna loop over each frequency. Then we're gonna loop over each pair of things in that frequency. We're gonna need a thing here. So we're gonna say what do they call them? Antinodes. Nodes equals, and that's just gonna be a set as well. And so we'll say, how are we gonna calculate this? If we remember looking at our example here, what we needed to do is, so if we want to go from here to here, let's do this one first. This one right here. We go over 2, down 1. So we want to go over 2, down 1 again. So we need to find this. We'll calculate the distance between these two. So it can be like dr equals r2 minus r1, and dc equals c2 minus c1. And now to calculate, to get the things, we've got this distance. So we just need to add this, I guess subtract this distance from this first one and add it to the second one. So I believe that means we will say antinodes dot add, and that will be, let's see, R1 minus dr. In fact, we probably don't even need a dr here, because if we, when we do this, oops, that's not, it's going to be R1 plus dr, I believe. Because we want to get, oh, sorry, it is minus dr. And if we actually plug this in for dr, it's actually going to end up being, because there'll be parentheses here, that ends up being 2 times R1 minus R2. That. And then the second point, comma, it'll be the same thing. 2 times C1 minus C2. I believe that is correct. We could check that again. We also got to go the other direction, so we can say antinodes dot add, and this one's going to be the opposite. So it's going to be 2 times R2 minus R1, 2 times C2 minus C2. C1. And we probably should put some spacing in here. All right, and now we might, I mean, that might be it. Oh, we have to check, we should check if they're in range. Let's save for a second, and let's just run this and see what it looks like. Oops. Combinations missing requirement R. Oh, we need a number. Okay. 2. And we have, let's see, antinodes. Let's see what these look like. What is the correct answer? I guess I should go ahead. The correct answer we're looking for is 14. And this is longer than 14, but we didn't take off the ones that are on there. So we'll say, I guess we're going to use our row things here. Okay, so we're going to say R comma C for R comma C in antinodes, like that. If 0 is less than or equal to R is less than or equal to, oh, it's less than num rows, and 0 is less than or equal to C less than num calls. And we don't want our C, we don't even really care what we put here. We can just put a 1. And in theory, we can then sum u. We can also len it 14. So we did get the right answer there. So we've just basically worked through and added these nodes together. We can also put this if up here. Okay, so we don't need u. We're not using u anymore. And we'll just add this filter. This is fine, the filter here. Oh, that's weird. I think we better check. That was supposed to be a C. So it should be 14. Okay. Looks good. Let's see if, a little shaky here. Let's see if this is actually right. 299. Beautiful. Okay, part two. Okay, so for part two, basically any two antennas form not only two antinodes, one on each side, but actually antinodes is every, periodically the same distance away. So like these two make 1, 2, 3, and then they go on forever, but we just need to worry about what's on the map. And so like these A's, you can just get the long line of antinodes straight up because they're just 1, 1 away. So the question is how many antinodes are on the map? All right. I don't think this is gonna be too hard. Let's see. Let's rename antinodes here to antinodes 1, and then we can make an antinodes 2 equals set like that. And what do we need to do? We're gonna go back. We do need a dr/dc after all, so we can say dr equals r2 minus r1. The signs here don't really matter as long as we are consistent. So like dc equals c2 minus c1, and because we're gonna go in both directions, it's fine. I think there's probably, let's see, what's the best way to do this? I think the way we're going to do this is we're going to say r comma c is equal to r1 comma, we're going to pick one of our points. And it doesn't matter which, we want, the points themselves do get added, part 2 said, so we're going to do that. So now we can say while 0 is less than or equal to r is less than num rows, and 0 less than or equal to c is less than num calls. So basically, as long as we're in the grid, we're going to start at our point and we're just going to start stepping. So we're going to say r plus equals dr, c plus equals dc. First thing we're going to do, we're going to add antinodes2 dot add r comma c. So we've added our thing, then we're going to step. Then we'll check. Are we still in bounds? If you go, add, step, check, etc. This is a little ugly, but I'm sure there's a more efficient way to do this, but it's not like immediately intuitive to me. We're just going to copy this. We're going to go back to our original point. It'll get added again, but it's a set, so it doesn't matter. And then now we're just going to minus. And so now we're going to walk both directions from the original point. Again, there's probably a more clever way to do this. I just don't, it seems this is the solution that seems like it's going to work for me right now. So it seems good enough for now. So when we get to the end, we're going to have antinodes 2. We've already checked if it's, they're already by definition all in bounds. So I think we just need to say len antinodes 2. I think we should probably make this len as well, just because I think len's a little faster than sum. I mean, irrelevantly so. And let's see here, if we go up and do our example, oops, generator has no len. All right, what do we miss? Generator, antinodes 2. Oh, we'll make that into a list. All right, why don't we go back to, if I don't know why that broke it, we can come back and fix that in a second, but if we're trying to just solve part 2, I'll come back to that. I don't know what's breaking there, but let's stick to this for now. So we have antinodes 2, a length of 34. That is the thing. Fingers crossed here. 1032. Boom, got it. Cool. This was not, I'm starting to get worried about when these are going to get really tricky, but this wasn't too bad. This part was the hardest part really to think through, and again, we did it kind of a sloppy way, but not bad. All right, what was breaking here? I'd make this a list and just save this. What's part 1 look like? Bunch of 1s. I should be able to say len. Oh, I bet I just didn't put I needed, I think I was doing parentheses or square bracket, and I just needed both. So silly. Okay. Awesome. Thanks for hanging out with me today. I'll be back tomorrow. Bye.